Determine all asymptotes of f of x equal 3x squared minus 2x plus 1 over x minus 1. First, we check to see if there is any horizontal asymptote. Since the degree of the numerator is 2 and the degree of the denominator is 1, the leading term in the numerator is 3x squared, has degree 2, and the leading term in the denominator is x, has degree 1. Since the degree in the numerator is more than the degree in the denominator, there is no horizontal asymptote. But if the degree in the numerator is 1 more than the degree in the denominator, then we will have a slant asymptote. To determine the equation for the slant asymptote, we will need to perform either long division or synthetic division. In this case, the divisor or the denominator is a binomial of the form x minus k, where k is 1. So we will perform the synthetic division. The coefficient of the numerators are 3, negative 2, 1. We bring down 3. 3 times 1 is 3, and then 3 plus negative 2 is 1. 1 times 1 is 1, 1 plus 1 is 2. And so the remainder is 2. The coefficient on the left-hand side of the remainder is the constant coefficient of the quotient, and the number on the left-hand side of it is the coefficient of x. And so this rational function can be rewritten as the quotient is x plus 1, 3x, not just 1x, because 3 is the coefficient of x. And so we read off the quotient from the last entry in the synthetic division, 3x plus 1. And the remainder is 2, and so we would do a plus 2 over x minus 1 over the divisor. We see that by looking at this, the quotient will give us the equation of the slant asymptote, and more than that, the remainder will give us the vertical asymptote at x equals 1. And so we have a slant asymptote y equals 3x plus 1, and we have the vertical asymptote x equals 1. Recall that this function 2 over x minus 1 resembles 1 over x, which is the reciprocal. It is shifted to the right 1 unit and stretched vertically by a factor of 2. And so when we graph this function, it will look like 2 over x minus 1, but at x go to infinity, the graph would follow or stay close to the slant asymptote y equals 3x plus 1. We're already done with determining the asymptotes of the function, but again, if we want to graph this function, we have a vertical asymptote at x equals 1. Usually, the vertical asymptote is not shown on the graphing calculator. We will have to put it in manually. The vertical asymptote in this case is x equals 1. We usually use a dotted line or dashed line for the asymptote. The slant asymptote is 3x plus 1, so it is the line that goes through y equals 1. This is y equals 3x plus 1. The vertical asymptote x equals 1, the slant asymptote 3x plus 1. At x go to infinity or negative infinity, the graph will stay close to this slant asymptote. And so we already say that the graph would look like the function 2 over x. The function 2 over x is the reciprocal function, but not quite at infinity and negative infinity in this case. The graph should follow the slant asymptotes at x go to infinity or negative infinity, and at x approach the vertical asymptote, the function increases or decreases without bound. Ideally, we should check the sign of the function for positive and negative. The break in this case is at x equals 1. So we would determine the sign of the function on the left and on the right hand side of the vertical asymptote. That should be easy because if we were to plug in x equals 2 into this function, we have 3 times 2 squared minus 2 times 2 plus 1 over 2 minus 1, which is a positive number. And then we check this any number on the left hand side of 1, we will see that it is negative. And also, we should find any x or y intercept. To find the y-intercept, we just simply plug 0 into x. 3 times 0 squared minus 2 times 0 plus 1 is 1. And then 0 minus 1 is negative 1. So 1 over negative 1 is negative 1. So the y-intercept is 0, negative 1.